Welcome back. The question that we have in front of us has to deal with linear graphs and linear equation. But before I go on to answering the question, I would like to introduce you to linear equation. Linear equation is always in the form y is equal to mx plus c. So y is the value that is given to you that is to be plotted on the y-axis. X is the value that is given to you that is to be plotted on the x-axis. M is what we call the gradient or the slope of the graph. Okay? And C is what we call the Y-intercept. So what is gradient? Gradient or the slope represented with the letter M is defined as the change in the Y divided by the change in the X values. So let's say you have the line representing the x-axis and that of the y-axis as shown here. And the yellow line is our linear graph. The 2 points on the graphs, let's say this is point A and this is point B. For point A, it has x and y values, right? So the value that is traceable on the x-axis, let's call that x1, and the value that is traceable on the y-axis at point A, let's call that y1. So it means the coordinates for A will be x1, y1. Moving on to point B, the value that is traceable on the x-axis, let's call that x2. While at the same point, the value that is traceable on the y-axis, we call that y2. So therefore, the coordinates at point B will be x2, y2. So the gradient represented with the letter M is defined as the change in the y divided by the change in the x value. That is to say, we will have y2 minus y1 divided by x2 minus x1. So that is the gradient, and this is the way you calculate it. It is also known as the slope of the graph. So moving on to the equation again, we said that y is equal to mx plus c, where c is called the intercept on the y-axis. So if you have the x and y-axis of your graph, and let's say we have the graph indicated with the blue line, the point where the graph cuts the y-axis is known as the y-intercept, and it is represented here with the green dot. Okay, so if you have your graph, the point where the graph cuts the y-axis is what we call the y-intercept. Okay, it can be a positive value or a negative value. Like in this case here, it is a negative value. Okay, so that is called the y-intercept. The x-intercept is where the graph cuts the x-axis, that is here. So the intercepts, whether y or x, can be found by equating one of the variables to 0. Let me explain that. So if I want to find the y-intercept, which is the same as c, then x has to be equal to 0. Right? It makes sense, because if this is the point where you have the y-intercept, x is 0, as you can see. So using the equation y is equal to mx plus c, y is equal to m, if x is 0, let's indicate that, plus c, we're going to have y is equal to c. So this is the y-intercept. It is the letter c that you have on the linear equation. But what if I want to find the x-intercept? For the x-intercept, y has to be equal to 0. Is that not so? This is the y-axis. So where is it 0? It is here. When it is 0, then you can find the x-intercept. So given the linear equation y is equal to mx plus c, if y is equal to 0, we're going to have mx plus c. So that is minus mx is equal to c. So if I want to know the x value, I will divide both sides by minus m. So therefore, the x-intercept is equal to minus c divided by m. So which means if we want to find the x-intercept, that is, we're going to divide the y-intercept by the gradient. Okay? So moving on to the concept of the acute and obtuse angle with the x-axis. This is the x-axis and this is our linear graph. So if they ask us to find the acute angle between the linear graph and the x-axis, that is going to be this. So that is the acute angle. Okay? An acute angle is an angle that is greater than 0 but less than 90 degrees. But if they ask us the obtuse angle, that will be the angle that we have between the horizontal line and the graph. That is this. So this is the obtuse angle. Okay? Remember, the sum of the acute angle and the obtuse angle will be equal to 180 degrees. So if this concept is clear, I will now move on to answer the questions that we have. The question that we have in front of us reads, using a scale of 2 centimeters to 1 unit on both axes, draw two perpendicular lines, OX and OY. Okay, so that is the axis that we have. Let's go on to indicate that on our graph, 2 centimeters to 1 unit. So this is the linear graph that we have in front of us. So now let's try to draw our x-axis. This is our x-axis. Okay, that is the x-axis. And let's move on to draw our y-axis. So this line is our y-axis. It says that we have to use 2 centimeters to 1 unit. So that is, after counting the first 2 centimeters, label it 1, 2, 3, 4, and 5. Then we move on to the opposite direction. minus 1, minus 2, minus 3, minus 4, and minus 5. That is for the x-axis from 5 to minus 5. So for the y-axis, we will have 1, 2, 3, 4, 5, 6. We move on to the opposite direction. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Okay, so that is it. For the y-axis, it says from 6 to minus 6. So as stated by the question, it says on the same graph sheet, mark the x-axis from minus 5 to 5 and the y-axis from minus 6 to 6. We did that. So let's just make a quick confirmation. All right, we have labeled our x-axis and our y-axis. And for the y-axis, it is from 6 to minus 6. And for the x-axis, it is from 5 to minus 5. These instructions are important to be followed. All right. Moving on to the next point, it says, plot on the same graph sheet, point A, which is 1 and minus 2.5, and point B is 4 and 5. So point A, x is 1, y is minus 2.5, and for point B, x is 4, y is 5. Then it says join AB using a ruler. So let's go to the graph and indicate point A and point B. This is the graph again. For point A, when x is 1, y is minus 2.5. So the point where these two meet is here. That is when x is 1, y is minus 2.5. That is point A. And for point B, when x is 4, y is 5. So this is the meeting point. That is point B. We are now instructed to join the 2 points. So we will take a ruler and join the 2 points as shown here. Now, if we should write down the coordinates again, for point A, x is 1, y is minus 2.5, and for point B, x is 4, y is 5. So that is the linear graph. If we should write the title, we're going to have the linear graph for coordinates A, which is 1 and minus 2.5, and B, which is 4 and 5. So this is how the graph is going to look like. So as you can see, from the graph, we can say that the x-intercept is 2. That is the point on the x-axis where the graph cuts is exactly at 2. If we want to know the y-intercept, that is the point where the graph cuts the y-axis, we can extend the graph to see that value. So I will extend the graph and see where it will come exactly. So as you can see, the graph cuts the y-axis at point where y is equal to minus 5. So the x-intercept is 2, the y-intercept is minus 5. Now let's go on to see what the question asks us further. The third question asks us to find the gradient of the line AB. We will move on to answer that. So we want to find the gradient of the line AB. We can select any 2 points on the graph to find the gradient. But since we are given the coordinates of A and B, we can use that as well to find the gradient. That will be simple for us. So we know that gradient M is the change in Y divided by the change in X, which is the same as Y2 minus Y1 divided by X2 minus X1. So what is Y2 from the graph? That is 5 minus what is Y1? Y1 is minus 2.5. So divided by X2 is 4. Then minus what is X1? X1 is 1. So that is, the gradient will be 5 plus 2.5, since minus minus is positive, divide by 4 minus 1. What is 5 plus 2.5? That is 7.5 divided by 4 minus 1 is 3. So therefore, 7.5 divided by 3, we will have the gradient as 2.5. So how do we find the y-intercept mathematically? Y-intercept, that is, if you have y is equal to mx plus c, we will equate x to be 0 and select any 2 points for x and y. So let's use x1 and y1 values. X1 is 1, y1 is minus 2.5. So if we use y equals to mx plus c, then y is minus 2.5 is equal to, the gradient is 2.5 into x is 1, then plus c. We'll have minus 2.5 is equal to 2.5 times 1 is just 2.5, then plus c. So what will we have? We're going to have minus 2.5 minus 2.5 is equal to c. That is minus 5 is equal to c. So therefore the intercept, that is the y-intercept, which is the same as c, is equal to minus 5. So what if we want to find the x-intercept? For the x-intercept, so that is where y is equal to 0. We've said that the x will be equal to minus c divided by m. So that will be minus c, which is the y-intercept. It is minus 5 divided by the gradient is 2.5. So we will have minus minus is positive, so that will be positive 5 divided by 2.5, and 5 divided by 2.5, we get 2. So that is why on the graph we are able to have 2 as the x-intercept. Okay, the y-intercept, even from our calculations, we were able to have minus 5. Okay, so although not part of the question, but if at all we were instructed to form an equation for this graph, we already know that y is equal to mx plus c. So with this general equation, if we should substitute the values that we have for the gradient and for the y-intercept, we will have y is equal to, the gradient is 2.5, so that will be 2.5x, plus the y-intercept is minus 5. So which means the equation will be y is equal to 2.5x minus 5. Okay, so this equation is the equation that is associated with this linear graph. So you can prove by substituting any value for x and see whether you'll have that corresponding value on the y-axis. Moving on to the last question. It says measure the acute angle the line AB makes with the x-axis using a protractor. So if you go back to the graph, this is the graph here. Where does the line AB, that is the graph, makes with the x-axis? It wants us to find the acute angle, okay? The acute angle, and that is this angle here. So this is the acute angle the line AB makes with the x-axis. If at all they ask us the obtuse angle, that would have been this angle here, okay? But we're going to stick on to the question. The acute angle, if we use a protractor to measure this angle here, we're going to have 68 degrees, okay? So if you place your protractor and measure the angle that is between the line AB and the x-axis, that is for the acute angle, you will have 68 degrees. If at all the question asks us to find the obtuse angle, that would have been this angle here, you will have 112 degrees, okay? So how do we calculate that mathematically, the acute angle? The acute angle is equal to, that is the theta acute, is equal to the tan inverse of the gradient. So if you calculate the gradient correctly, you will be able to have this answer exactly. The gradient is 2.5. So the tan inverse of 2.5 is 68.1985. So that is approximately 68 degrees. Okay, that is how you find the answer. Thank you very much for watching this video. Please subscribe to the channel, like and share our videos.